In this video, I'm going to show you how to propagate uncertainties. What that means is use the uncertainties you get from your measurements in your calculations to get a final answer with a plus or minus value. Okay, as we get started, let's talk about some of the types of error or uncertainties we can get. First of all, in this case, I'm going to be using a ruler. It's analog, which means I can see that in the millimeters on my ruler, there will be a place where it might be almost to 1 or not quite. And the difference is with digital, you are given an exact value, and you don't know how close you were to the value shown on the scale. With the measurement from this ruler, I will be plus or minus 0.05 centimeters or plus or minus 0.0 millimeter, half of the smallest unit that you can see. I know my value is going to be somewhere in there, but I don't know exactly. Another way we can have random uncertainty is if we take multiple measurements of the same thing. And in one of my other videos, I show you how to do that from your data using range divided by 2 to get an uncertainty of the group of measurements. I also want to point out in this case, if you take a look, this ruler does not start with 0 right at the edge of the ruler. And if I ignored that, that means that all of my measurements would be out by this much right here. And that would give me a systematic error. A systematic error in your data means that all values are affected by the same amount in the same direction. Now, if I take my ruler, I will move it around and I will try and measure it. In cases like this, where you could have a high amount of variation, you should take 3 measurements. Now, when I've done this, I get 11.3 centimeters. We call decimal 0.5 the absolute uncertainty. It creates a range plus or minus a absolute or positive value from our measurement. So let's go on and start actually using uncertainties to do some calculations. For example, I've got 2 different geckos here, and what if I want to know what the total length of geckos are? So I'm going to take my ruler, I'm going to move it, and I'm going to measure the length of each one, and let me write those down. Okay, so when I measured, my larger gecko was 8.0 centimeters. Now, one thing I do want to point out is this decimal 0 is quite important. What that says is I have measured the length of this gecko to the nearest millimeter. Without it, I'm telling the reader that I've only measured to the nearest centimeter. It's one of the reasons why zeros to the right of a decimal at the end are significant. It tells you about the precision of the measurement. And the smaller one, I have 5.3. Now, if I was just ignoring these uncertainties and adding them together, we would say 8.0 plus 5.3 equals 13.3 centimeters. So let me show you about how to use these with uncertainties. So I've already said that with this ruler, I measure to the nearest 0.05 centimeters. So that means I've got a maximum value that could have been was 8.05 and a minimum of 7.95. Likewise, for the other gecko, it would have been a maximum of 5.35 and a minimum of 5.25. So if I wanted to calculate what the maximum would have been, including my uncertainties, that means I'm going to take this value 8.05 and add it to this value 5.35. If I want the minimum length possible, then I will take the 2 smaller ones and add them together. So if I was considering uncertainties, I know that my length is somewhere between 13.2 and 13.4. And if you remember, if I added the 2 numbers together, I had 13.3 if I ignored the uncertainties. Another way to think about this is my total length is going to be 13.3 plus or minus 0.1. And what I want to point out here is that 0.1 is actually just adding the two uncertainties together. So the rule is when you're working with uncertainties, you just add the absolute uncertainty. Okay, so that was great for addition, but let's try something that involves subtraction. So how much longer is the bigger gecko? If I'm going to calculate this, first of all, let's again find the maximum difference between them. I'm going to find the difference between 8.05 and 5.25. Likewise, for the smallest possible number, I'll use 7.95 and 5.35. Okay, so if I ignored the uncertainties, I would have got the value of 2.7. When I calculated the greatest difference, I got 2.8, and the smallest difference, 2.6. So just like before, I'm going to have a value somewhere in between the two of these, and it just the same way is going to be the answer we had when we ignored the uncertainties, plus or minus adding the two absolute uncertainties together. Even though this is subtraction, we will still add the uncertainties. Okay, so let's take this a little bit farther. I've drawn a box around my gecko. Let's say for some reason I need to find the area of that box. So first of all, let me take my measurements. So in this case, I got 8.2 and 3.2 for the width. Now one thing to realize is that these errors are relative to our measurement. So then if I multiply my length by some value, the error that I have would also be multiplied. So using the absolute uncertainty will not be appropriate in this case. So what we're going to do is calculate the percentage uncertainty. So what percent is 0.05 compared to 8.2? Because that relative value will stay constant. So here is what I've got for values: 0.061% for the length and 1.56% for the width. Now I'm keeping all the decimal places in my calculator for now, and you'll see what I'll need to round later. A couple things I want to point out is, first of all, the shorter length you notice here has a greater percent uncertainty, even though I was using the same ruler. It's one of the reasons why when we do line of best fit and we calculate the gradient, we should choose 2 points that are far apart as possible. It will reduce the percentage uncertainty in our calculation. Okay, so I just need a bit more space. Here's what we're doing. We're calculating the area, and here are our values: 8.2 plus or minus 0.61% error times 3.2 plus or minus 1.56. So the first part, do the multiplication like you would normally do. And I get 26.24. Now I need to add my percent error. Just like before with addition and subtraction, except for it's not the absolute, it is the percentage error. In this case, I'm going to get 2.17%. Now let's move that back and calculate what 2.17% of 26.24 is. You get 569. Now here's something I want to point out. This is our uncertainty. Now how is it that I can be that certain about an uncertainty? When you say that out loud, it should be, huh? So the rule is our uncertainty can only ever have one significant figure. So that means it will need to be rounded. This isn't because, oh look, I've made a mistake with my calculator. It's because it is an estimate and you can't be exact with an estimate. So in this case, I should have 0.6. We also have now that my uncertainty is plus or minus 0.6. That gives me a certain amount of precision. And if you take a look, the value I have here calculated has more precision than I have for uncertainty. So our next step is to round our value so that it matches the precision of the uncertainty. So now I have a final answer. My area is going to be 26.2 centimeters squared plus or minus 0.6 centimeters squared. So multiplication and division will work in the same way, just like addition and subtraction work the same way. Let me go through the steps one more time. I first calculated my answer like I would normally do, 8.2 times 3.2. I have my percentage uncertainties and I've added them together. Next, I turned that percentage uncertainty into an absolute uncertainty. I rounded it to one significant figure, and then I rounded my answer to match the precision found in my uncertainty. So if you look in your data book, you'll find this box. What it's saying is if y equals a plus or minus b, then the uncertainty in y, that's what the delta is implying, would be the uncertainty in a plus the uncertainty in b. This plus or minus here is not referring to b as an uncertainty, but rather if I'm using addition or subtraction, the rule will be I add the absolute errors. Now you can see in this case, I have a times b divided by c. I have then the percent uncertainty. Okay, so this is the plus or minus value in my final answer divided by y is going to be the percent uncertainty of a plus the percent uncertainty of b plus the percent uncertainty of c. It doesn't matter if they're multiplied together or if it's division, I use the same rule. They also have this one here about if you have a value to an exponent. Now you can do this as it's the absolute value of the percent in a, or you can realize that a to the n just means, just like here, if it was a square, you would take the percent uncertainty in a, adding it to itself. So just to summarize what we've done, when adding or subtracting values with uncertainties, they use the same process. We will take our uncertainty that comes from our measurement, or perhaps from range by 2 if we were analyzing data, and we will add the absolute uncertainties. For multiplication or division, I'll have to take that absolute uncertainty from my measurement and I'll turn it into a percentage uncertainty compared to the value. Again, I will add the percentage uncertainties and then go through our calculations. Finally, our uncertainties can only have one significant figure. You can't be exact with what you don't know. I hope this video will help you with your calculations for your internal assessment, or it could also become on paper 3 in section A where you have the experimental section.